let's run through some rules and laws for working with exponents. First, I want to do a quick review of how we actually do computations with exponents. Let's start with the expression 2 to the 4th. That means we're multiplying 2 by itself 4 times. So 2 times 2 times 2 times 2 would give us 16. If we have negative 2 to the 4th, notice there are parentheses, that means we are taking negative 2 times itself 4 times. 4 negatives is going to give us a positive, and we also get positive 16. However, if I don't have parentheses around the negative 2, this exponent of 4 only applies to the 2. It does not apply to the negative. Exponents only apply to the thing just to the left of them. So in this case, my answer is going to be a negative, and then I'm just taking 2 times itself 4 times. That gives me negative 16. All right, so how do we do various types of algebraic simplification with exponents? Let's start by considering the example x to the 3rd times x to the 4th. Before I give you a rule for this, let's actually write it out and see what happens. X to the 3rd means we have the product of 3 x's. X to the 4th means we have a product of 4 x's. If we multiply all these together, I can visually see that if I just count the number of x's, there's 7 of them. 3 plus another 4 is 7. So I have x to the 7th. Now, that's not actually a coincidence. It turns out anytime we multiply and we have the same base, both x's, we can actually add the exponents. 3 plus 4 is 7, so x to the 3rd times x to the 4th is x to the 7th. We call this our product rule. We also have something called the power rule, which applies when we're raising an expression with an exponent to another power. So let's consider the situation where we have x to the 3rd squared. X to the 3rd means you have 3 x's multiplied together, and if you take that and square it, you're doing that twice. So you've got 3 x's times another 3 x's. Altogether, that would be the product of 6 x's, which is x to the 6th. Now, a faster way that we could get this answer is we can actually take 3 times 2 to get that 6. That's what we call the power rule. Finally, I've got one last example to show you, our quotient rule. So for dividing, and let's say we have an x to the 5th divided by x to the 3rd. So 5 x's in the numerator being divided by the product of 3 x's. Well, we can treat this like a fraction and we can reduce. We've got a common factor of x 3 different times. We can cancel those common factors out and we're just left with 2 x's or x squared. Another way, or a faster way of getting this answer, is we can take the exponents and subtract them. 5 minus 3 is 2. So to summarize, here are our 3 different laws of exponents. The product rule: when you multiply things with the same base, we add the exponents. The power rule: if we raise an exponential to a power, we multiply the exponents. And finally, our quotient rule says when we divide, we subtract the exponents. So let's see how this works by doing several examples that involve multiple rules to simplify. So let's start by trying to simplify a squared b to the 3rd times ab to the 4th. This is a product. We're multiplying various terms with the exponents together. So I start with the a's. A squared times a, that's like an a to the 1. Product rule says we add the exponents. 2 plus 1 is 3, so that's a to the 3rd. Then I have b to the 3rd times b to the 4th. Add the exponents, that gives me b to the 7th. And that's my final answer. This simplifies down to a to the 3rd, b to the 7th. Here's another one. This is similar. We have another product rule problem. 4x squared y times 2x to the 5th y to the 7th. So this problem has coefficients in it, numbers in it, and we can just multiply those as we normally would. In fact, with multiplication, we can multiply in any order we want. So we start by just doing 4 times 2 is 8. Then I take x squared times x to the 5th. It's a product, so we add the exponents, and that gives me x to the 7th. Finally, I have a y to the 1 times y to the 7. Add the exponents, that gives me y to the 8. And that's my final answer. My next example involves a combination of rules. Just like when I'm using PEMDAS, or order of operations, I'm going to get rid of the parentheses first. I have a y to the 3rd raised to the 5th. This is a power rule situation, and we multiply the exponents. 3 times 5 is 15, so that becomes y to the 15 times y squared. Now we have a product, so we can add the exponents. 15 plus 2 is 17. Final answer, y to the 17. All right, let's do a couple more examples. Next one, I have the quantity 2a squared to the 3rd times 3a to the 5th. This is similar to the previous problem, except we do have some coefficients here. But the first step is to get rid of the parentheses. Deal with the fact that we're going to cube my 2a to the 3rd. That power of 3 is going to apply to everything in the parentheses. It applies to both the 2 and the a squared. So that becomes 2 to the 3rd. And then with the a squared, we multiply the exponents. 2 times 3 is 6. So that becomes 2 to the 3rd, a to the 6. And then we still have that 3a to the 5th. 2 to the 3rd is 8. 2 times 2 times 2 is 8. So now I've got 8a to the 6 times 3a to the 5th. 8 times 3 is 24. a to the 6 times a to the 5th, we add those exponents. 6 plus 5 is 11, and so my final answer becomes 24 a to the 11th. This next example is going to involve the quotient rule. We are dividing, and so we're going to subtract the exponents. And we always take the exponent on top minus the exponent on the bottom. So x to the 3rd divided by x squared, 3 minus 2 is 1. That becomes x to the 1. Y to the 10th divided by y to the 5th. I do 10 minus 5 is 5, so y to the 5th. And there's my answer, x, y to the 5th. W to the 3rd times w to the 8th divided by w to the 4th. So this problem is going to involve multiple rules, and there aren't any parentheses, so it turns out the order you do the rules in actually doesn't matter. But I'm going to use my product rule first and multiply w to the 3rd times w to the 8th. Because that's a product, we can add the exponents. 3 plus 8 is 11. So now I've got w to the 11th divided by w to the 4th. We subtract the exponents. 11 minus 4 is 7, and that gives me an answer of w to the 7th. This next example has parentheses in it. It has a product. It has a quotient. We're going to have to use all those different rules in this problem. I'm going to start with the parentheses first. P to the 3rd to the 4th, we multiply the exponents. As well as in the denominator, I have a p squared to the 5th. I'm going to multiply those exponents too. So that's going to give me p to the 12th, 3 times 4 is 12, times p to the 6th. And then on the bottom, I'll have a p to the 10th, because 2 times 5 is 10. Then I'm going to use the product rule on the numerator. P to the 12 times p to the 6 is p to the 18. I added those exponents. 12 plus 6 is 18. Finally, I'm going to subtract the exponents. P to the 18 divided by P to the 10 is P to the 8. 18 minus 10 is 8. That was my last example in this video. We're going to continue with this topic but expand on it in the next video.